In this video, we're going to learn how to be able to conduct a chi-squared goodness of fit hypothesis test. In the first question, we're going to discuss the color distribution of the peanut M&Ms. According to the manufacturer of M&Ms, 12% of the peanut M&Ms in the bag should be brown, 15% yellow, 12% red, 23% blue, 23% orange, and 15% green. A student randomly selected a bag of peanut M&Ms, and he counted the number of M&Ms that were of each color and obtained the results that we see on the table below. Notice that is our observed frequency. What we want to do is we want to test whether the peanut M&Ms in our bag follow the distribution that is stated by the manufacturer of M&Ms, and we're using a 5% level of significance. The first thing we want to be able to calculate is the expected value. How many did we expect to be of each particular color? In order to be able to do that calculation, the first thing I did is determine the total number of M&Ms in the bag. And you notice the total number of M&Ms is the sum of the frequency column, which we can get by using the summation notation. Now what we want to do is set up a formula for the expected frequency. So of course, every time we have a formula, we have the equal sign. We take n, which is the number of M&Ms, is 400. And since we want that to be used for all of the cells, we make that a fixed cell. Again, on a PC, it is the F4 button, which is on the function buttons on top of the numbers. Or we use the compose T, it's 4 on the Mac. Now we're going to multiply that by the percentage that we would have expected to be brown, which is 12%. Notice we expect 48. We copy that formula. So we know the expected value of the number of M&Ms we would have determined in the 400 M&Ms of each particular color. Now we're going to state the null and the alternative hypothesis. The null hypothesis states that the distribution of M&Ms is the same as stated by the manufacturer. Alternative, we believe that we want to be able to determine if the distribution or the percent distribution is different than that stated by the manufacturer. What we're going to do is we're going to get the p-value, which tells us what percent of the time would we expect the number to be different. Is it significantly different? In order to go there, we use the chi-square test. So we go to our formulas, we go to our statistical, and we go to our chi-square test. Now for the chi-square test, we need two pieces of information. We need the actual range, that is what we observed, so we put down the numbers from 53 to 59. The expected values, the expected range is what we thought we would get using the expected value formula. And notice we get our percentage of the time that would happen, which means it's approximately 61% of the time. Now we want to state our conclusion. So to state our conclusion, we go to determine our p-value, and the easiest way to do that is to say equal, and then just copy this particular number. So we see the number, and we have our approximately 62% compared to our level of significance, which is 5%. Now we notice the p-value is greater than the given level of significance of 5%. Since the p-value is greater than the alpha, we state that the results are not significantly different. Therefore, we do not reject the null hypothesis, and we believe that the percent distribution of the color of peanut M&Ms are approximately the same as those stated by the manufacturer. We're going to go to a second question. This time we don't have any percentages to start with. And we want to be able to determine if the sick leave of the number of people who actually call in sick is significantly different on any one of the days during the week. So let's see what we're reading. A supervisor at Fast Track Professional Temporary Services suspects that her employees are more likely to call in on Mondays and Fridays than any other day of the week. To test this claim, she collects the data on the number of people who call in sick on each day of the week. Her data is summarized on the following table, and we want to test the claim that the relative frequency of days in which employees call in sick is not equal for the 5 days of the work week. Now, and again, we're using a 5% level of significance. Well, the first thing we want to be able to determine is basically how many people called in sick. Well, in order to get that, again, we're going to go equal sum because we want to get the sum of a particular number, and we want to get the sum of the numbers of people who call in sick for the 5 days of the week, and therefore we have 47 people who called in sick. Now, even though we have that, since we don't have any percentages, we go on the basics that the number of people who call in sick every single day will be approximately the same. Therefore, in order to do that, we're going to take our 47 and we're going to make that a fixed cell. And we're going to divide that by the 5 days of the week. We can also make that a fixed cell. And therefore, every number will be approximately the same for each particular day. It's not letting me make it fixed. All right. And then we can just copy this straight across. Since we put in the number 5, we don't have to make it fixed. And we would expect approximately 9 4/10 of a person to call in sick. Now, we're not going to get 4/10 of a person, but this tells us that is the number. Now, we state our hypothesis test, saying the distribution of the number of people who call in sick is the same for each day, versus it is approximately different for each day. Again, we go into our chi-square test, and we can go to recently used since we have already done that. We have the actual range goes from as low as 7 all the way up to 13. We have the actual number, which is 9 4/10 every single day. And that tells us about 58% of the time, it'll be approximately the same. Now, again, we are going to get our p-value by just copying that information. Because we have our p-value, and I'm going to make it look approximately the same, so I'm going to go home and I'm going to add an additional decimal digit. And again, since it's 5%, I want the same number of decimal digits, so it's easy to compare that. And again, we notice that the p-value is greater than the given alpha. Again, there is insufficient evidence to suggest that the relative frequencies are not all equal. Therefore, we do not reject the null hypothesis, and the supervisor will have to say that approximately the same number of people call in sick every day of the week versus more on Mondays and Fridays.